easy go.
Hello everyone, I'm Connor and welcome to the podcast. Today we will be breaking down ICT DSE topics and exam tips. Our guest, Dr. Tech, will be joining us today.
So in this podcast, we'll be breaking down the essential building blocks of modern computing from the CPU to GPU, and also the difference between RAM and ROM, and also the registers. Not only that, we'll also be breaking down on how operating systems manage hardware through processing systems such as real-time processing or batch processing, and for each concept will be explained with relevance to DSE style questions. So you guys will be having the skills to actually answer these questions.
First question, what is the difference between a CPU and a GPU?
Now, CPU is basically the brain of the computer. So it basically executes all the instructions using the fetch decode cycle. It will fetch the instructions from the memory, it will decode it, then it will execute. And the GPU is more specialized for repetitive performance calculations. They're mainly used for gaming, mainly used for basically processing graphics.
How about memory? What's the difference between RAM and ROM? How does CPU store memory?
So what are the differences? So RAM is volatile and very fast. So meaning that when the computer is shut down, the currently used memory will be gone. But for ROM, it is non-volatile and permanent. So basically the whatever was being used will be saved on the computer, and it also serves the firmware, aka BIOS. So CPU memory storage, the registers. Now we have the program counter, also the PC. It is basically a register that tracks the memory address of the next instruction to be fetched and executed by the CPU. It increments automatically during the fetch decode execute cycle. So how about the accumulator? So the accumulator holds the immediate results and their arithmetic and logical operations that are performed by the ALU. So here's an example tip. So cache and registers. Now you have to know the difference because they are very, very important. So registers, they hold data and instructions that are actively being used by the ALU, and it's the smallest capacity of all memory types, but the absolute fastest speed. But for cache, it stores the frequently used data and instructions that are fetched by the RAM. So it will anticipate what the CPU will be needing next. It's faster than RAM, but slower than the registers. So it's good to not mix these two up together. Otherwise, you'll be losing marks.
All right, then it's time to move on. Next topic is OS. So tell me, what is an OS?
So what is an operating system? So without an operating system, hardware is just expensive metal. It can't really be used for anything at all. So it basically brings the computer basically to life by managing resources, coordinating components, and also enabling every task that is performed. So it handles these tasks by doing processing with processing methods. So there are four processing methods. So the two we're going to be discussing now here is real-time processing. So it's instant processing, which is basically it has no responses in real time. So the response will be immediate. So the real-time processing systems will process the data and it will give you immediate responses. But batch processing, what it will do, it will collect a large group of data and it will run similar tasks and it will be processed all at once. And they can be used usually off at peak hours. So here's the other two, which I'll be discussing. So parallel processing would basically break down complex tasks into smaller and independent subtasks. And for each subject, they can be handled either separately, enabling efficient workload distribution across multiple processing units. And there's distributing processing. So it is similar to parallel processing, but instead of processors, they use computers, physical computers connected by a network. Here's an exam tip. For parallel processing, it will occur inside one single machine. The OS will divide a complex task into smaller parts and it will execute them simultaneously across multiple cores or a CPU, which within a computer. And for distributed processing, it will spread across multiple distinct physical computers.
All right, well, we are coming to the end of the podcast, but before the end, there are a few questions our guests want to ask to you listeners.
Before I end this podcast, I have a few questions. Here's a quiz. So, which of the following statements about memory components in a computer system is or are correct? So, option one, cache memory has a larger storage capacity than RAM, but is slower to access. Question two, registers inside the CPU are used to hold immediate data and instructions during the fetch, decode, execute cycle. And statement three, ROM is non-volatile and is used to store data. They're currently being used by an application program. Question two, a smart television uses both RAM and flash memory. Explain why television still requires cache memory even though it already has high-speed RAM. Question three, an electric company accumulates all smart meter readings throughout the month and calculates electricity bills for all city households at midnight on the first of every month. Which type of operating system processing function is most suitable for this scenario? A. Real-time processing. B. Batch processing. C. Parallel processing. And D. Distributed processing. Now, for the final question, a logistics company is deciding whether to upgrade their system using high performance mainframe computers supporting parallel processing or a network of multiple standard computers supporting distributed processing. Say the fundamental structural difference between the parallel processing and distributed processing. To end off in a conclusion, data lives in the secondary storage and it will move to the RAM when open and it will be zipped into cache for quick access, manipulated inside the CPU residues. Always decides real time, batch, parallel, or distributed processing. And this is the end of my part. Thank you for listening.
This is the end of the podcast.